In previous videos, we've discussed how to find probabilities involving the standard normal distribution. So, say for example, find the probability that z is less than -1. Okay, so here's -1 to the left of 0, and basically this question is asking me to find this area, right? So I go to my table and I look up -1, and I see it's 0.1587, so equals 0.1587. Okay, so we've discussed how to do that. Now, what if the problem is slightly different? Okay, in this video, we're going to discuss problems that are kind of the opposite of these sort of problems, where they've told us that the area, for example, say they've told us to find the corresponding z-value that corresponds to the area being 0.1587. 0.1587. And they're asking, what is this z-value? Okay? So we would have to do this slightly different. We would go to the table and we'd look inside of the table for 0.1587, and we'd say, oh, well, that's the corresponding z-value. It's -1. Right, and we'd say, oh, okay, well, that z-value equals -1. Okay, so that's what we're going to talk about in this video, is how do you find the z-values when you provide it with probabilities. All right, so let's go ahead and get to our examples. First example, find the 95th percentile of the standard normal distribution. So let's draw this out. Okay, let me try to draw that line. Okay, so here's 0 in the center. 95th percentile. Now remember, that means that 95% of the distribution is behind whatever the 95th percentile is. Okay, that's what percentiles mean. 95% of the distribution is less than that value. Okay, so it's going to be way over here, right? And 0.95% of the distribution, so the probability of being less than whatever this unknown z-value is, it's going to be 0.95 over there. Okay, so I'm looking for what is that z-value? What is that z-value where 95% of the distribution is to the left? Okay, so I'm going to go to my table. Now I know inside of this table it gives me the area to the left of any particular z-value. So it's not going to be on the negative z-scores because that's all really small z-values. So I need to go over to the positive side. Over here we have larger z-values, right? And I'm looking for 0.95 for the area. I'm looking inside of the table for 0.95. All right, let's look carefully. Let's do like a search here. So 0.95, we might not find it exactly, but hopefully we'll find it really close. Oh, you see it right there between 0.9495 and between 0.9505. Actually, 0.95 is directly between those two numbers. Okay, so because 0.95 is directly between those two numbers, we'll want to take the z-value that's directly between 1.64 and 1.65. Right, the z-value that's between 1.64 and 1.65, that's, let's see, that'd be 1.645. Okay, so what's the value of this z-value? What's this z-value? It's going to be approximately 1.645. So what's the 95th percentile? 95th percentile is 1.645. All right, let's do another example. Find the area, find the z-value such that the area under the standard normal curve between 0 and this z-value is 0.2123. Okay. Actually, for this problem, we're going to have to make an assumption. This z-value, it either could be positive or negative. So we're going to make the assumption that it's going to be positive. Okay. So I'm going to put it over here on the positive side, right? You could have solved this problem on the negative side. You would have, so I guess there's two right answers to this question. Okay, so I'm going to put that z-value over here. It's some unknown z-value, right? I'm trying to figure out what is that z-value, right? Okay, I know that the area between 0 and that z-value is 0.2123. All right. Now, when I go to my table and I look up, I can't look up 0.2123, right? The table doesn't give the areas between 0 and some number. No. The table will give the area behind this z-value, right? It'll give all of this area, right? All of this area behind whatever this z-value is, all of the area behind. Okay, so what's this area back here? Back here behind 0? Well, that area back there is 0.5, right? Half of the distribution's less than 0, right? I could look that up in the table if I forget that, but actually, if you look up 0 in the table, it'll tell you it's that is half of the distribution. It's 0.5 there. Okay, well, so if I'm looking for this z-value, where the area behind that z-value is going to be 0.2123 plus 0.5. So 0.2123 plus this 0.5, right? That's the total area behind this z-value. Okay? Okay. So let's add that up. That'd be 0.7123. Okay, so let's go to my table and let's look for the area that is 0.7123. Okay. Okay, so I'm looking inside the table for 0.7123. 0.7123. All right. Oh, wow, there it is. There it is, 0.7123. Okay, so the corresponding z-value is 0.56. That's my answer, 0.56. So the z-value is 0.56. All right, let's go on to another question. Find the z-score z-scores, this is more than one z-score they're looking for, that separates the middle 95% of the standard normal distribution. All right, so let's draw this out. Okay, so here's 0 in the center. Okay, middle 95%, that'd be here. 0.95 is in the middle. Okay, so we're looking for this z-value and that z-value. Actually, since this distribution is symmetric, and we've put 0.95 exactly in the middle, they'll be the same numbers. This number will be negative because it's to the left of 0, and that number will be positive. But they'll be the exact same number. Okay, so I only need to find one of them. All right, well, I'll go ahead and find the negative one because if I find the negative one, I just need to know, well, what's this area back here? If I find that area back here, that'll tell me, what number I should be looking up in my table, right? Because remember, the table gives the area behind a certain number, right? If I were to look up the positive z-value, then I would need to calculate all of this area, which you could do just as easily, right? Okay, but let's go ahead. Let's try to find this purple area. Now, the total area under the curve is 1, right? Total area under the curve is 1. Okay, so I have already accounted for 0.95 of the area under the curve. So I have 0.05 unaccounted for. So that 0.05 is going to be showing up here and here. It's going to be showing up in the tails. All right, I got to split that 0.05 evenly because the distribution is symmetric. So I have 0.025 on each tail. Okay, so the area in this tail is 0.025, and the area in this tail is 0.025. Okay, so I need to calculate, and I need to look up in the table what z-value has the area behind it of 0.025. Okay, let's go ahead and look at our table. Okay, we're going to be going to the negative side because I'm looking up for the negative z-value. Looking inside the table for 0.025. 0.025. There it is. Negative 1.96. Negative 1.96. Okay, so the negative z-value is negative 1.96. The positive z-value then will be positive 1.96. All right, there we go. Okay, one more example. Find the z-score that separates the top 10% of the standard normal distribution. All right, so let's draw this out. Here in the center is 0. Okay, separates the top 10%. So here is our unknown z-value, and above it is 10%, or 0.1, right? So probability of being more than this z-value is 0.1. Separates the top 10%. All right. I can't look up 0.1 in the table. That's not going to make much sense, right? Because what the table gives me is the area behind the z-value that I'm looking for. So what's the area behind this z-value? Well, if that's 0.1, then this area behind should be 0.9, right? 1 minus 0.1. My total area is 1. So 1 minus 0.1 is 0.9. Okay, so I just need to look up in the table for 0.9 and then find the corresponding z-value, where the area behind this z-value is 0.9. All right, let's look in our table for 0.9. All right, yeah, that'll be in the positive side. So I'm looking over here, 0.9, looking inside the table for 0.9. Okay, 0.9. All right. This is another one where it's between 2. Okay, but it's not exactly between. Do you notice this? This 0.8997, that is closer to 0.9 than 0.9015, right? 0.9015 is 0.0015 away from 0.9, versus this is only 0.0003 away from 0.9. So this one is closer. So when you end up in this situation, you want to take the z-value that is closer. Okay, so you're going to be doing, this is an approximation. We're limited by our table, but you want to go ahead and you want to take the z-value that is closer to the real probability that you're looking for. Okay, so I'm going to use this 0.8997. I'm going to go ahead and use this area. Okay, so that is 1.28. Okay, so the z-value is 1.28. Okay, and that is my answer. That's the value that separates the top 10% of the standard normal distribution.